Hello students, welcome back to our YouTube channel Geeks for Geeks, Gate Computer Science and Data Science. So till last video we have covered LU decomposition. So we have seen that how to break a matrix into lower triangular and upper triangular matrix and get the results accordingly. And later on we have seen that using LU decomposition how to find out how to solve system of linear equation. Now in this video we are going to start a new topic, that is eigenvalues and eigenvector. So the question arises that what are these eigenvalues and what are those eigenvectors, right? So I'm just telling you the definition. What it says that, let's suppose x be a non-zero vector, and when I say that non-zero vector, it doesn't mean that it does not have any zero value. It means at least one of the value should be non-zero, right? At least one of the value. So I say that if we have a non-zero vector, let's say A is a square matrix, A is a matrix of order n cross n, and x is a non-zero vector such that I get that Ax is equals to lambda x. So if I am able to find out any such vector such that I'll multiply it with matrix A, I'll get a scalar value and the vector itself. So I'll say that this x is nothing but my eigenvector. This is my eigenvector. And what is this lambda? This lambda is called as eigenvalue. So eigenvalue is the scalar lambda and eigenvector is a vector which I'll multiply with the matrix. I'll get the vector itself with a scalar multiplication. Right, so that is my Ax equals to lambda x. So now we know that what is eigenvalue, what is an eigenvector. If somebody asks you, you would tell that. But how to find out eigenvalue and eigenvector? That is a question. So let's see. So I said that x is a non-zero vector. X is a non-zero vector such that I have said that Ax is equals to lambda x. Now I just want to find out that how to find out the values of lambda or x, because if I'll try to solve using hit and trial, there are so many possibilities, I'll not be able to solve it. So what is the method to find out eigenvalue and eigenvector? So what would I do? I'll write down Ax minus lambda x. I have taken this lambda x to the left hand side, right? Now can I write down this as A minus lambda I into x is equals to 0? What it become? It becomes system of linear equation. A minus lambda I and this x vector, but I do not know lambda, तो मेरे को ये matrix भी नहीं पता, this x vector भी नहीं पता. We know one thing, if you guys remember, if we know one thing, this homogeneous system of linear equation has two types of solution. Either unique solution which is zero solution, or we have infinitely many solution which is non-trivial solution. And zero solution cannot be here, because at the start we have taken that x is not equals to 0. So that means this system should have infinitely many solution. And we know that this Ax equals to 0, agar if I have this homogeneous system of linear equation and I want infinitely many solution for this system, when I get that, when determinant of A is 0, or I'll say that A is a singular matrix. We have said that if I want non-trivial solution, determinant of A should be 0. So here I can write down, because for this system I want infinitely many solutions. So can I say that here, that what would happen? Determinant of A minus lambda I would be 0. What would happen? I'll take determinant of A minus lambda I, that would be 0. Now with the help of solving this, I'll able to find out the eigenvalues. And this, you would get a polynomial, because you would subtract each of the diagonal entries with lambda and you would take a determinant of that. What would you get? You would get a polynomial, and you call this polynomial as a characteristic polynomial. Characteristic polynomial. And we know that how to find out, or this is called as characteristic equation. If somebody asks you what is characteristic polynomial would be only determinant of A minus lambda I. This would be your characteristic polynomial. This is characteristic equation because I am equating it with 0. Now we know that how to find out roots of this characteristic equation. If I'll find out roots of the characteristic equation, roots of this polynomial, what would it become? What would it would give you? It would give you those roots would be nothing but your eigenvalues. Eigenvalues. Now what I'll do later on, I'll substitute those eigenvalues in this equation to get a eigenvector. So let's do for a 2 cross 2 matrix this thing, and we'll get to know how to work on eigenvalues and eigenvector. Like we'll show a detailed method for that. But in general, in gate level questions, we usually do not solve using a longer method. But first we are going to see that first how to find out eigenvalues and eigenvector. So we have this question. This matrix is given to us, 2 cross 2 matrix. I need to find out eigenvalues and eigenvector. So we know that to find out eigenvalues, I have to solve this equation, determinant of A minus lambda I. Right? A is this matrix. I would be an identity matrix 1 0 0 1. And if I'll find out A minus lambda I matrix, what it would be? What would be this matrix? This matrix would be 4 minus lambda 0. 3 minus lambda, this would be not 0, 4 minus lambda 2 1 3 minus lambda. This would be my matrix, 4 minus lambda 2 3 minus lambda. Right? Now what would I do? I'll solve determinant of A minus lambda is equals to 0. So determinant of what matrix? 4 minus lambda 2 1 3 minus lambda. I'll equate this determinant. What would I get? 4 minus lambda into 3 minus lambda minus 2. This is a determinant, AD minus BC. That's the same thing I have done here. Now let's multiply. 4 3s are 12 minus 4 lambda minus 3 lambda plus lambda square minus 2 is equals to 0. Lambda square minus 5 lambda plus 7 lambda plus 10 is equals to 0. Right? I got a characteristic equation. This is nothing but my characteristic equation. Characteristic equation. And somebody asked me characteristic polynomial x square minus 7x plus 10 or lambda square minus 7 lambda plus 10, whichever variable you want to use. Now for eigenvalues, what I need to do? I need to solve this equation. So let's find out the root. So everyone knows how to find out roots of a quadratic equation. So you should know that how to find out roots of quadratic equation and cubic equation. So I had just done the factorization. So I got eigenvalues 2, 5. I got 2 eigenvalues 2, 5. And because it has degree 2, for a 2 cross 2 polynomial, for a 2 cross 2 matrix, we'll get a characteristic polynomial of degree 2. So we'll get 2 roots. There might be a possibility that they are distinct, they can be same, but we'll get 2 distinct eigenvalues, not more than that. So that is the procedure for eigenvalues. But the question arises, what about eigenvectors? So for corresponding to each of the eigenvalue, definition, like you guys can see the difference. What we have studied any vector x such that ax into x would gives you lambda x. I have started the definition with the eigenvector ki I need a vector x, right? But how I am finding out? I am finding out first the eigenvalues. Now later on what would I do? I'll find out corresponding eigenvectors. And how I am going to do that? First I am writing here eigenvector corresponding to eigenvalue lambda equals to 2. Corresponding to 2, I am going to find out eigenvector. Right? So the question arises that how I am going to find out that. So let's see now how we are going to find out the eigenvector. So what would I do? I'll just substitute a minus 2i x 0. I need to solve this system of linear equation, so I get the eigenvector. A minus lambda I x 0 mila tha. I got this here. To find out, this is a system I got to find out the eigenvector A minus lambda. Lambdas I have solved. Once I get this lambda, I'll get this matrix. Now I can find out the value x. Right, so same thing I'm going to do here. So let's see. Yeah. So A minus 2ix. So what was my A matrix? A matrix is 4, 2, 1, 3. So I'll just subtract 4 minus 2, 2. And 3 minus 2. So I get this matrix. This is x1, x2. And this is 0, 0. Right, this is my system. Now to solve this system, I can only take the coefficient matrix. I do not need to take all these matrices, right? We already have solved that, we know. So I'll take this matrix 2, 2, 1, 1. Now I'll apply the operation. R2 tends to R2 minus 1 by 2 R1. So I got 2, 2 and this is 0, 0. Rank is 1, so 1 would be my free variable. Obviously you would always get, for eigenvalue you would always get a free variable because you have here infinitely many solution. So x1 is fixed. Let's say x3 is your free variable. I am writing here x3 free variable. यहीं पे लिख देती हूँ, वहाँ पे उसके लिए सॉल्व कर, चलो ठीक है यहीं पे लिख लेते हैं. x3 is my free variable. Sorry, not x3. x2 is my free variable. x2 is my free variable and equation is 2x1 plus x2 is equals to 0. Right? Now I want to find out an eigenvector. So x1 would be minus x2. So what would be the solution? How I have written the solution? Minus x2, x2, x2 I can take common, minus 1, 1, x2. It has infinitely many solution, but it has single vector that is linearly independent. So if I'll take this, so eigenvector corresponding to eigenvalue lambda is equals to 2 is, I got the eigenvector minus 1, 1. This is my eigenvector minus 1 and 1. Right? Now same thing I'll do for eigenvector corresponding to lambda is equals to 5. Let's do that. Now I'll find out eigenvector corresponding to eigenvalue lambda is equals to 5. And if you try to solve it by taking any another value lambda 2 and 5, if you would take any another value instead of lambda 2 and 5, you would get the vector as 0, 0, 0, 0. So the only infinitely many solution possible for 2 and 5. For 2 and 5 you would get the eigenvector. Now let's try to solve it. So our matrix was 4 minus 5 minus 1 and 1 2 and यहाँ पे क्या था, let's check ने सही भी लिखा है क्या, just a minute. Matrix क्या थी मेरी, matrix was 4 2 1 3, उल्टा लिख दिया ना. एक मिनट. Matrix was 4 2 1 3 ना, 4 2 1 3. So 1 ऐसे ही रहेगा, 3 minus 5 minus 2. This would be your a minus 5y ना, a minus 5y, and instead of writing x I am writing here 0. Right? I am writing here 0. Just a minute. Okay, so now I'll solve it. I'm writing it 1, you can write down it x as well, y1 y2, and the right side is 0 0. Now what would I do? I'll row reduce this matrix. Let's row reduce it. Minus 1 2 1 minus 2. I'll row reduce it. What would be the operation? R2 tends to R2 plus R1, right? What would I get? Minus 1, 2, 0, 0. Again, one free variable, rank 1. So minus x1 plus 2x2 equals to 0. So x1 would be 2x2. So what would be the solution? Solution would look like, how does the solution look like? x1, x2, 2x2, x2, and it would be 2, 1, x2, right? So what would be the eigenvector corresponding to? Now you can check that if you would write down eigenvector corresponding to lambda is equals to 5 is 2, 2 and 1. So we get two eigenvalues, two distinct eigenvalues, and corresponding to that I got two eigenvectors. Two distinct eigenvalues, and corresponding to that I get two eigenvectors. Now I'll try to find out eigenvalues and eigenvectors here as well. Let's try to find out eigenvalues and eigenvector. So what would I do? What would be the first step? Why I am taking this question? Because you would get to understand that eigenvalues are always not, like it is not always true ki you would get eigenvalues distinct, right? If you are getting same eigenvalues, then what would be the procedure? So let's see, I'll solve determinant of a minus lambda. Let's say determinant of a minus lambda for eigenvalues. What would I get? 1 minus lambda, 1, 0, 1 minus lambda and 0. So I'll solve it. 1 minus lambda square is equals to 0. On solving, I'll got eigenvalues as 1, 1. These are my eigenvalues. One thing you can check here, that your eigenvalues are now not distinct. Eigenvalues are not distinct. If eigenvalues are not distinct, what would I was simply doing eigenvector corresponding to eigenvalue 1. I got this. I want to find out eigenvector. ठीक है, क्योंकि 1, 1 है, 1 से ही निकाल सकते हैं. We cannot take any another value. So I am finding out eigenvector corresponding to eigenvalue 1. So what it would be? A minus 1i capital X vector, that would be 0. So I'll write down, the matrix would become 1. On solving, it would become 0, 1, 0, 0. This is x1, x2. This is already in row reduced format. So I do not need to row reduced it further because it is already in row reduced format. So on solving, what you would get? x2, 0, x2, 0, because first non-zero entry we have here. So x1 is your free variable. x2 I got 0 and x1 I got as my free variable. So what would be the solution now? Solution, I am writing it here, x1, x2. Solution would be x1 is free variable and x2 is 0. So solution would be 1, 0, x1. So eigenvector corresponding to lambda is equals to 1 is 1, 0. So you can see that I have repetition of eigenvalues. Eigenvalues, obviously, if you have power 3 cross 3 matrix, you would get 3 eigenvalues. There might be possibility that they are repeated. 4 cross 4 eigenvector, 4 cross 4 matrix, you would get 4 eigenvalues. There might be a possibility that the eigenvalues are repeated, but you would get the order would be the same as number of eigenvalues. So I got 2 eigenvalues, but number of eigenvectors may or may be less than equals to number of eigenvalues. Eigenvalues 2, but I got 1 eigenvector because they are repeated. But now the question arises ki if every time the eigenvalue is repeated, can I get only 1 eigenvector corresponding to that? Guys, are you getting my question? My question here is that whenever I have a repeated eigenvalue, so for corresponding to 1 eigenvalue, can I have only 1 eigenvector? This is a question. With 1 eigenvalue, can I get only 1 eigenvector? Let's see this thing. Let's see one question. Yeah. I have this matrix. So the question is find the eigenvalues and eigenvectors. I'll solve determinant of A minus lambda I 0. So matrix would become 1 minus lambda 0 0 1 minus lambda. I have just taken a simple matrix to make you understand the concept of eigenvalues, right? So I got 1 minus lambda square is equals to 0, lambda is equals to 1 comma 1. Eigenvalues we got the same, but now I'll find out eigenvector corresponding to lambda is equals to 1. So what would I do now? I'll find out eigenvector corresponding to lambda is equals to 1. Right, so what would I do for that? I'll solve A minus 1i, and then again capital X is equals to 0. I'll get 0 0 0 0 because A is an identity matrix itself. So I'll got the vector x1 x2 0 0. Can you guys think of the solution here? Just pause the video and think what can be the solution here. What would be the values of x1 and x2 here? How would you solve that? Right, that is a question. Na? If you would see that there is no pivot entry, no first non-zero element in the matrix. So that means both the variables are free variable. So can I say that x1 is my free variable and x2 is also my free variable? I can take any values for that. So how my solution looks like? Solution looks like x1 1 0 and x2 0 1. So you can see that we have one eigenvalue 1 corresponding to one eigenvalue. We got two eigenvectors. When we have more number of free variables corresponding to one eigenvalue, we can get more number of vectors. So what we have seen, first I am writing here eigenvectors corresponding to lambda is equals to 1. I got the vector as 1 0 and 0 1. Right, these two would be my eigenvectors. Now one thing if you would notice here is I got this matrix, I got two eigenvalues, two distinct eigenvalues. With each eigenvalues there is an eigenvector associated with it, right? There is an eigenvector associated with it. But later on what I have seen here that if I have a matrix which gets repeated eigenvalues, now corresponding to those repeated eigenvalues I got one eigenvector only. We have two eigenvalues 1 comma 1, but corresponding to 1 I got only one eigenvector. And then later on I got the information that I got repeated eigenvalues, but corresponding to that as well I got two eigenvectors. So corresponding to one eigenvalues there can be more than one eigenvector, but how many eigenvectors are possible? So let's write down some of the properties which we can take from here. Let's see some of the properties we can take it from here. Okay, so first of all, if A is of order n cross n, A is a square matrix of order n cross n, then I can say that A has at most n eigenvalues, n distinct eigenvalues, या फिर सबसे पहले ये लिखो कि if A is a square matrix of order n cross n, then A has n eigenvalues. N eigenvalues होंगे. And now I'm writing in bracket specifically, if I'll mention specifically or particularly, A has at most n distinct eigenvalues. n distinct eigenvalues, right? N distinct eigenvalues. So total eigenvalues would be n, but distinct eigenvalues can be less than n because we have used the word at most. So that is for eigenvalue. Now next thing come for eigenvector. Corresponding to each eigenvalue, corresponding to each eigenvalue, number of eigenvectors associated would be less than equals to number of times the eigenvalue is repeating, the eigenvalue is occurring. So that means, let's suppose eigenvalue 1 is occurring 2 times, so I can have at most 2 eigenvectors. I cannot have more than 2 eigenvectors, right? If there might be a possibility that I'll have 1 eigenvector, but at least there will be an eigenvector. Less than equals to, and, or you can also write down that for each eigenvalue there is always an eigenvector associated with it. There would always be an eigenvector. ऐसा नहीं होगा कि we'll not have a eigenvector associated. There is always an eigenvector associated with it, right? So these are some properties which we get by solving the questions for a 2x2 matrix. But also what we are going to do, we are going to discuss further on the topic, like some of the properties of eigenvalues and eigenvectors which help us to solve eigenvalues for a 3x3 matrix or a 4x4 matrix, because you can see that this method is literally very lengthy. You can see that first I'll find out the eigenvalue for 2x2 matrix, then later on for corresponding to one eigenvalue and corresponding to another eigenvalue. So you can see that it is too much time taking to find out eigenvalues and eigenvector like in this manner. So we are going to discuss some of the properties, and we are going to see that how we are going to find out eigenvalue and eigenvector using properties. And also one more thing, if you would see here that these properties, you can see that right now you feel like that is not important, but these properties would be helpful when we are going to discuss diagonalizability, because then we are going to define algebraic multiplicity and geometric multiplicity given. Okay, I'll write down only here as well. What is algebraic multiplicity? Algebraic multiplicity of an eigenvalue. What is algebraic multiplicity? It would be helpful when we are going to discuss diagonalizability. So algebraic multiplicity of an eigenvalue, number of times that eigenvalue is repeating. That is your algebraic multiplicity, right? And geometric multiplicity, of an eigenvalue is number of eigenvectors associated with the eigenvalue. Right? So this is my algebraic and geometric multiplicity. So if I'll talk about in this question, what is algebraic multiplicity of 1? 2. Geometric multiplicity of 1, because 2 eigenvectors, so 2. Algebraic multiplicity of 1 is 2, and geometric multiplicity here is 1 in this question. And in previous one, in this we got two distinct eigenvalues. Geometric multiplicity of the eigenvalue 2 is 1 and algebraic multiplicity is also 1. Geometric multiplicity of the eigenvalue 5 is 1 and geometric multiplicity of eigenvalue 5 is 1. Geometric and algebraic multiplicity both are same. So diagonalizability says that if matrix all eigenvalues have same geometric multiplicity and algebraic multiplicity, then matrix is diagonalizable, otherwise it is not. So we are going to discuss it later when we are going to discuss about diagonalizability in detail. But till then guys, you remember about definition of algebraic and geometric multiplicity. Now in next video we are going to work further on our eigenvalues and eigenvector. So that's all for this video. We are going to continue in the next one. Thank you.